Hi, this is Ms. Schenck, and we're going to continue our notes on gas laws. This time we're going to talk about two new laws, Avogadro's law and Dalton's law of partial pressures. So, Avogadro's law states that equal volumes of gas at the same temperature and pressure contain an equal number of particles. So now we're bringing particles into our discussion. So if you think about the number of particles, think about how many collisions you can have. Proportion equation, V is proportional to N. An example would be if you think about what we've talked about before when we were talking about moles. At STP, so that's standard temperature and pressure, and according to Avogadro's law, we want to say same temperature and pressure. So at STP, that's 0 Celsius, 1 atmosphere of pressure. There are 22.4 liters of any gas will contain 6.02 times 10 to the 23rd particles. Now, if that pressure were slightly different than the same volume, we would have a slightly different amount of particles. Or vice versa. If we had the same amount of particles, we'd have a slightly different amount of volume. Dalton's law of partial pressures. Dalton's law of partial pressures is defined as the sum of the partial pressures of all the components of a gas mixture is equal to the total pressure of the mixture. The equation is P total equals P1 plus P2 plus P3, etc. So let's look at a couple of examples for Dalton's law. For Avogadro's, we didn't have any examples. We just want to keep that in mind for when we start talking about the ideal gas law in the next session. Okay, here's our first example. What is the atmospheric pressure if the partial pressures of nitrogen, oxygen, and argon are 604.5 millimeters of mercury, 162.8 millimeters of mercury, and 0.5 millimeters of mercury, respectively? We just use our equation for P total. It's all the partial pressures added together. This case, there are three partial pressures. Let me fix this down here. We have the 604.5, the 162.8, and the 0.5. If we had another gas in here, then we would have added that as well. So that's why I said plus, etc. When you add those up, that's 767 millimeters of mercury. Sorry, 767.8 millimeters of mercury. Okay, let's look at another example. If the total pressure of a system, so this time we have the total pressure, containing nitrogen, oxygen, and carbon dioxide is 105 kilopascals. So that's your total pressure. Partial pressures of nitrogen and oxygen are 67 and 32. What is the partial pressure of carbon dioxide? So this time we're going to solve for something over here. We're going to solve for P3 actually. Alright, I'm going to go ahead and plug in my numbers. I've got 105 equals 67 plus 32 plus whatever that P3, or in this case I just wrote pressure carbon dioxide is. So I added the 67 and the 32, that makes 99. And do you know how to finish this? You should subtract 99 from both sides. So the pressure of carbon dioxide is equal to 105 minus 99, which is 6 kilopascals. So that is Dalton's law of partial pressures. We're going to use both Avogadro's law, Dalton's law of partial pressures, and all of the laws we talked about getting to the combined gas law in the next session to talk about the ideal gas law.